jejunum and the ileum. This topic, along with there is one more small topic that is called the mesentery. That is nothing but the fold of the peritoneum that suspends the walls of the small intestine. Now, this topic, as usual, again from examination point of view, what is relevant to be can be asked as a 3-marker or 5-marker question, as a short note or essay. Short. Differences of small intestine and large intestine. Other than that, they even ask you related to differences between the jejunum and ileum as well. And with respect to the mesentery, again can be a 5-marker question as a contents in the mesentery that we will see in the next coming slides. So to begin with, this small intestine. Once I hope you must be familiar by now the stomach, the beginning of the GI tract, the stomach. So after that, continuation of the stomach is nothing but the stomach will continue from the pyloric end as a beginning of the small intestine. So as you can make out from this diagram as well, so wherein this shows the stomach as well as the pyloric end. So continuation from this is the entire length of the structure of the small intestine. Now, small intestine as such has 3 parts divided into the duodenum first part, then the upper 2/5 is jejunum, and the rest of the part is the ileum part of the small intestine. So anatomically, if we say that it extends from the pyloric part of the stomach or pyloric end of the stomach till the ileocecal junction. So this is the part of the large intestine that you can see over here. So the cecum and the ascending colon appendix is also seen over here. So, but this is the point wherein the ileocecal junction, wherein considered to be the second end of the terminal end of the small intestine. So that is how we anatomically define the extent of the small intestine. Now it is said to be like a dimension-wise, the length-wise, if you say it is said to be almost 6 meters long. So almost 6 meters, almost 18 to 20 feet in length. So 6 meters long. So it is quite a long, which is quite a long. So every the length itself denotes that it is essential. This length, such a quite a longer length, extended length of 6 meters, essential, or which is essential for digestion of the vegetative or we can say the plant-based food rather than the non-vegetative or the carnivore type of wherein in those animals the length of the small intestine would be this much longer, as you can see in the herbivores or the people or animals who are by birth are supposed to be adapted to the digestive adapted to the digestive system is adapted to the vegetative food. So that is how the length, and as I said, there are 3 parts. I did the duodenum, the jejunum, and the ileum part. Now we'll look into that exactly further certain details related to the small intestine as well. Now this part of the small intestine, the beginning of the small intestine, as you can see, is the duodenum. So this part is called as the duodenum. This is said to be almost 25 centimeter long. So this entire length of duodenum extends up to 25 centimeters long. Now the remaining part is that what we discussed, we are going to discuss today. So this will be dealt in again in the coming classes, duodenum, which is again itself a very important topic that will be dealt in detail. So today we will restrict ourselves to the jejunum and ileum. So let's talk about now what you can make out here. So this part is the one which is the jejunum and ileum. Now this is considered to be more or less a fixed part. So duodenum is considered to be more or less a fixed part. So fixed in the sense it is closely applied to the posterior abdominal wall. So that's why duodenum is said to be retroperitoneal and it is fixed to the posterior abdominal wall. So that is how the duodenum anatomically mentioned to be retroperitoneal and to be more closely approximated to the posterior abdominal wall. Now it has its own region, whereas compared to the jejunum and ileum, they are free. They have the freedom of mobility because it has to, which is mainly concerned. Jejunum and ileum are mainly concerned with the digestion and absorption of the food and the peristaltic movement. So that is the reason why the rest of the part, that is the jejunum and ileum, they are considered to be intraperitoneal and has free motility, so that the peristaltic movement can happen without any hindrance. So that is all. Now, whereas with respect to, in contrast to the duodenum, so it is said to be retroperitoneal and fixed. Now, the reason for being retroperitoneal and being fixed to the posterior abdominal wall, it has a very important reason, almost three reasons. So the one of the reason is the duodenum has to receive the chyme from the stomach, the partly digested food of the stomach that enters into the duodenum. That is one reason it has to be fixed, so that it should not, even if the duodenum was intraperitoneal, so if it is suspended, if at all, if it was suspended by the fold of the duodenum, so every chance is that it might kink, or it might cause, it might even lead to twisting across the level of the duodenum. That again might hinder the process of propagation of the food and digestion as well. That's the reason why duodenum is said to be retroperitoneal and being fixed to posterior abdominal wall. For one reason, it will receive the chyme from the stomach. Then apart from that, as you can make out in this diagram again, so apart from being one, it has to receive the food, partly digested food from the stomach. Number two, we can make out over here, the hepatic ducts under conferences you can make out. So duct is a common bile duct is opening into the second part of the duodenum. Other than that, again, at the same simultaneously, even the pancreatic duct, so main pancreatic duct will also open into the second part of the duodenum. So this is the second part of the duodenum as you can make out. So that is the reason why. So it will receive, the duodenum will receive from three different sources: food, or that is partly digested food as a chyme from stomach, then the bile which is secreted by from the gallbladder, which is stored in the gallbladder, will be poured into the duodenum, as well as the pancreatic juices or enzymes that are secreted by the pancreas is also directly poured into the duodenum. So that is the reason why. So if it is intraperitoneal, or if it is suspended by a fold of the peritoneum, every chance is that it might get kinked, or it might kink, or it might get twisted, leading to hindrance in the further digestive mechanism. So that is how the essential role of the duodenum is served by being retroperitoneal. Whereas if we look into the duodenum and if you look into the rest of the parts of the small intestine, that is the jejunum and ileum, so they are primarily concerned with absorption, digestion and absorption of food, and the peristaltic movement. So that is the reason why they have the liberty of being mobile to be suspended by the fold of the peritoneum. That will see that there is a mesentery. So mesentery is one of the, that is part of the fold of the peritoneum that suspends the spoils of the small intestine, is called as mesentery. So that we'll see that in the coming slides. So that is about as an introductory note to the jejunum and ileum, as well as briefly about the duodenum. So duodenum, mind you, is again an important topic that will be dealt in detail in the coming classes. Now this is just a brief differentiation between the duodenum and the rest of the small intestine. So as I said, it is a duodenum to be 25 cm long, it is almost approximately 6 meters long, supplied by the has specifically two rows of plasa recta, so source of blood supply to them. So it has one single row of plasa recta with respect to small intestine, be it jejunum or ileum. And the most important, the characteristic feature in the duodenum you might have seen with respect to the histology. In the submucosa, there will be aggregation of the mucosecreting gland, which are called as the Brunner's gland. So that is the classical or the characteristic feature of the duodenum, which is evidently absent in the small intestine. So that is how the differences. This is just a brief differences between the duodenum and the rest of the small intestine. Whereas in detail we'll see in the next class, coming classes. So now we'll go ahead with slighter details about the duodenum as well as the jejunum as well as the ileum. Now, as we have seen, now if we, both the jejunum and ileum is further differentiated into the upper part to be called as the jejunum and the rest of the part is called as the ileum. Now again, though there is no clear-cut or definitive anatomical differentiation between jejunum and ileum, but they divide the rest of the small intestine, excluding the duodenum. So they divide in such a way that upper 2/5 of the small intestine will form the jejunum, whereas the rest of the lower 3/5 of the quite longer compared to the jejunum. So the lower 3/5 of the small intestine, the remaining part of the small intestine is nothing but the ileum. So that is how they differentiate. Now, or it extends from the jejunum and ileum extends from this region over here. So where the duodenum ends. So duodenojejunal flexure or bend. Flexure means a bend. So duodenojejunal flexure till the ileocecal junction. So that is how the extent of the rest of the small intestine, that is the jejunum and ileum, can be mentioned to be extending from the duodenojejunal flexure to ileocecal junction. So somewhere over here where the duodenum ends, the duodenum in turn has its 4 parts, as being first, second, third, and the 4th part. So this particular approximately will be the duodenojejunal junction to be extending till the ileocecal junction. So that is how it extends. So as I said, there is no definitive demarcation between the jejunum to the ileum. As I told you earlier, as we have seen earlier as well, so both these points of the small intestine, excluding the jejunum, that is the jejunum and ileum, they are suspended from the most abdominal wall by this fold of the peritoneum, which is called as the mesentery. So that we'll see that again in the coming slides, in the next slides. That is how the mobility of the rest of the coils of the small intestine is facilitated by this attachment, that is the mesentery. Now, we'll briefly look into the structure now of the jejunum and as well as the jejunum as well as the ileum. Now, if you take a cross section of the jejunum or ileum, what it can be found as to be consisting of 4 layers. If you go from inside outwards, so the 4 layers are named or labeled as the innermost would be the mucosa, then slightly just outward of the mucosa would be the submucosa, further outward of the submucosa would be the muscularis or muscular layer, and outermost covering the layer of the intestinal coil would be the serosa with the connective tissue and the peritoneum. So that is how the structure of the jejunum, structure uniformly. If you take a cut section to jejunum or ileum, consists of these basic 4 layers, as you might be aware by this time. So mucosa inside outwards, mucosa, submucosa, as you can make out in the diagram. So this one has to be the mucosa, then the submucosa, then the muscular layer, and this is the serosal of the tiny tissue of the peritoneal layer. So that is how the layers of the small intestine as such can be noted. Now this is again a diagram suggesting the cross section of it. So you can make out the first arrow mark represents the mucosa. So this second arrow mark represents the layer of the submucosa, and the third arrow mark representing the muscular layer, and the fourth arrow mark representing the serosal layer of the small intestine. So there are certain features as well. So apart from once we know the four layers, that the intestinal wall or the intestinal the jejunal and the ileal coils has 4 layers, and there are some quite an quite an interesting features and features that are relevant and worth remembering. Now this is these features are with respect to the mucosal layer. So now the what would be these features? Now one thing we know that primarily the function of the jejunum or the ileum and the ileum would be the digestion and absorption. So to facilitate or to increase the or to enhance the process of digestion and absorption of the nutrients which are present in the lumen. So there are certain features. One feature would be as is also called as the planka circularis, also called as the walls of Kurkring. So planka circularis or walls of Kurkring. So what exactly? Now these actually can make out in the animated diagram over here. You can make out the anterior one of the wall of the small intestine has been removed, reflected. Then you can make out the interior of the coil of the small intestine. You can make out these lines. These lines represents these represents the folds of the mucous membrane. So these would be in circular pattern, so running all across the circumference of the circumference of the lumen of the small intestine, so that will be the jejunum or the ileum. So those folds of the circular folds of the mucosa are called as the walls of Kurkring or plica circularis. That is what it represents. This is the characteristic feature again in the jejunum or the ileum. So that is very, very important. Now these walls are present in such a way that these walls or these folds or circular folds are such a way they are present in such a way that even if you stretch the wall of the circumference is stretched, so it will not be obliterated. So it will not be flat. So it will not get obliterated. So they are considered to be, that's why they use the term called as, they are considered to be the permanent folds of the mucosal folds, which are circular. So those are nothing but the plica circularis or the walls of Kurkring. So that is one characteristic feature. Other than that, now on the walls of the Kurkring or the circular folds or the plica circularis, there will be numerous microscopic structure projections, finger-like projections on the mucosal layer. So those projections are called as villi, as you might be aware again. So these projections, what you are seeing over here, they are called as the finger-like projections are called as villi. So they do again increase the surface area. Main purpose is to increase the surface area, so for better absorption and the digestion of the food which is present within the lumen of the small intestine. So the almost dimension will be almost, they are as smaller as less than 0.5 millimeter or even less than that. So that those folds also, that's why they are considered microscopic projections of the mucosal layer of the intestine. Whereas upon the villi, there are again further projections, further again microscopic projections which are called as the microvilli. So they do again just like villi, they also increase the surface area for better absorption and digestive process. So those microvilli, you might be aware earlier with respect to general histology. So they give a spread and borderline appearance on the surface of the mucosal layer. So those are called as microvilli. So these are like this is one of the features. Under that, you can say about two sub features with respect to the mucosa. So the main feature in the mucosa would be the plica circularis or the circular folds or walls of the Kurkring. On the walls of the Kurkring, so there will be finger-like projections which are less than 0.5 mm of projections which are called as villi. And upon the villi, so there will be again very minute structural projections which are called as microvilli. So that is how they increase the surface area for better absorption. So this is again an histological diagram showing all the 4 layers of the wall of the small intestine, be the jejunum or the ileum. So if you go from now, this considered to be the lumen of the intestine. This is the mucosal layer of the small intestine, which even shows numerous glands over here. So mucosecretory glands. So whereas this would be the submucosa, what you can see over here. So submucosal layer. This is the muscular layer, and outermost would be the serosal layer. So this is a histological diagram of the wall, means showing the 4 layers of the intestine, that is the small intestine, that is jejunum as well as for with respect to breast of the jejunum and the ileum. Now the second feature with respect to mucosa, we are still in the mucosa. We said shows certain feature. One among that was the lichen circularis. On that there was villi as well as there was microvilli. And the second feature is, as you can make out in this animated diagram again, so this will be the lining epithelium. On that epithelium you can see the microvilli, so it can be clearly made out of this image. So that was the villi and microvilli can be seen over in this diagram. So the second feature with respect to the mucosa will be they are called as something called as the crypts of Laverton. Now crypts of Laverton, they are nothing but if you wish to describe the crypt of a Laverton, they are nothing but the lining epithelium of the villi. So when it projects or invaginates into the lamina propria of the mucosa, so this area is called as the lamina propria. So when the lining epithelium is addressed, it projects or it invaginates into the lamina propria over here in the mucosa. So these are again continuous further to the fellow villi. So this particular crypt or the invaginated structure in the lamina propria is called as the crypt of Laverton. So crypts of Laverton are one of the characteristic feature in the small intestine, jejunum and ileum. So the main function would be, so they will be helpful for the better digestion absorptive function. So they will aid the circulate the digestive enzymes and the mucous secretion. So from these will be secreted from this crypts of Laverton. So that is again crypt of Laverton, or also called as intestinal gland. Apart from the other feature, first feature what we saw is the walls of the covering for the first feature in the mucosa. Second feature is the intestinal glands of the crypts of Laverton, which in turn produces digestive enzymes to aid the absorption process, digestion and absorption process. But in the second feature of the mucosa, the third most important feature which maintains the immunity of the intestine would be presence of or having or to be having the lymphatic aggregation, aggregated lymphatic tissue in the form of nodules, which are called as lymphatic follicles. These lymphatic follicles where are they located? So again, primarily the lamina propria of the mucous membrane, that is the connective tissue of the mucosa. So lamina propria, that is the appropriate location of the lymphatic follicles. Now further, for descriptive purpose, depending on the amount of aggregation of the lymphatic tissue, there are two types. So one is a solitary follicle or a nodule, so which is almost about 10 which are much more smaller in size, microscopic though. So they are said to be present throughout the length of the small intestine. So that is how the lymphatic follicle in the form. Lymphatic follicle can be in the form of jejunum and the ileum. So Peyer's patch is nothing but the aggregated lymphatic tissue or nodule or the follicle, which are again seen in the lamina propria. Which are seen in the lamina propria of the mucosa. So the earlier we said that solitary lymphatic nodule or a follicle. Again, the slightly larger one, a larger version of that is nothing but aggregated. After being isolated or the solitary. So this is the aggregated follicular lymphatic follicular presentation. Now this entire region which has been marked over here. So this is considered to be the Peyer's patch. Now the Peyer's patch, when we said that it is nothing but aggregation of lymphatic follicle. So the aggregation will be approximately about 250 solitary lymphatic follicles. When they come together or seen together at that particular point in the length of the small intestine, so they are called as Peyer's patch. So each Peyer's patch, if you further evaluate it, almost about approximately 250 lymphatic follicles would have been aggregated at that particular spot or the region. So that is called the Peyer's patch. So the length varies almost, since it is a quite aggregation of quite a number of follicles. So it extends from ranges from about 2 to 10 centimeter long. So each that is how, imagine the lymphatic follicle, lymphatic aggregation is in the form of solitary as well as aggregated follicle. So that denotes the immunity that is needed to be maintained in the at the level of the small intestine. So that is how it will function. Now they are like exactly where exactly these pairs patches are to be located. So now they are specifically mentioned as they are to be seen or noted in at the level of the anti-mesenteric border or across the anti-mesenteric border. So that is where you can make out the Peyer's patch. So if at all you wish to locate the Peyer's patches, so best to locate them across the anti-mesenteric border. Now what is this anti-mesenteric border? Now this is just an animated diagram showing the attached border over here. I can make out, we consider these are the coils of the small intestine. Now coils of the small intestine, now these are the coils of the small intestine. So coils of the small intestine, they are suspended by these arrow marks, suggesting the arrow marks like appearance. So that is nothing but the mesentery. So this is the fold of the peritoneum. By the fold of the peritoneum, these coils are suspended. So now the borders, I mean the jejunum and ileum can be considered can be descriptively divided to be having two borders, a mesenteric border and the anti-mesenteric. The part or the point where the coils of the small intestine are suspended by the fold of the peritoneum, that is called as the mesenteric border. Whereas exactly opposite to that, when it is free over here, so there is no attachment. So this particular part opposite to that is called as the anti-mesenteric border. So if you wish to locate the Peyer's patches, so they are present across the anti-mesenteric border. So across over here, opposite to the point where the mesentery is attached. So that is called as anti-mesenteric border. So they are small and circular and few in the distal part of the jejunum. Then again the amount of Peyer's patches or number of Peyer's patches slightly varies. Now if it is the distal part of the jejunum, they are considered to appear to be smaller and circular. Whereas as you go towards the ileum, the size and shape of the Peyer's patches becomes much more larger, oval and numerous in number comparatively. So that is what the difference between the Peyer's patches to be seen in the jejunum and to be seen in the ileum. So as you move towards the ileum, so the Peyer's patches size increases and number also increases. That is the reason is almost the food is entering towards the large intestine. That is nothing but undigested food. So undigested food, every chances that it might the bacterial multiplication can happen. So that is the reason why. So to maintain the immunity, so we come across more number of Peyer's patches is a larger to be seen more in the ileal part rather than in the jejunal part. So now this is a image just to make you understand which is the mesenteric and anti-mesenteric border. So this is just one of the coils of the intestine. As you can make out, this is the mesentery, the fold of the peritoneum. Now you see this is the anti-mesenteric border. So the point or the region where or the part of the intestine where it is which is away from the mesentery. So this is the mesentery, fold of the mesentery, what you can see. So this is the mesenteric border of the coil of the intestine. This is the anti-mesenteric border. So that is where the Peyer's patches can be best located. So that is about the features with respect to mucosa. So we have seen with respect to mucosa to be having three features. One is the plica circularis. Second feature, plica on the plica circularis there were villi and microvilli. The second feature was related to the this one. The second feature was with respect to this one, so that is the intestinal line in the form of crypts of liberum. So what we have seen earlier to be very helpful for digestive purpose again, facilitating digestion, crypts of liberum. Whereas the third feature was the lymphatic follicle. It can be the form of solitary or aggregated lymphatic follicle. So those were the features with respect to the mucosa. Now we look into something, some sudden feature with respect to the submucosa. The submucosa is this one. This region as you can be put here after being the mucosa entirely. So this is the submucosal layer. Now nothing much as a specific or exclusive feature here. The mucosa, the submucosa consists of a tissue layer along with blood vessels, nerves, lymphatics, and more importantly, plexus, autonomic plexus of nerve, that is the business plexus of nerves are also seen in the tuberosal layer. Whereas the muscular layer, muscular is external as it is also called as. Now this is the muscular layer as you can make out over here. Now this layer, muscular layer. Now again for better descriptive purpose, consists of two layers. It is inner circular and outer longitudinal. So that is how the arrangement of the smooth muscles which are to be seen in the muscular layer has to be inner circular and slightly outer longitudinal. So that's what is made up of, outer longitudinal, inner circular arrangement of the muscle fibers, and we'll learn it in detail in the histology part. So now between these two layers in the muscular layer, so there is again a autonomic plexus that is called as or back plexus of the nerves. So this is also one of the features related to the muscular layer. So those were the features related to the walls of the small intestine, that is jejunum and ileum. Now other aspect related to this one would be, as you can see from the which is written from the diagram over here, especially a person suffering from typhoid fever, so a bacterial infection again. So you can make out the ulceration with a quite large ulceration, so which is said to be oval shape and vertically present. So it is vertically present and it is oval in shape. So that is how the typhoid fever ulceration is characteristic feature depending on the site and location. Because since again there is again a person suffering from going through typhoid fever, so that is because of larger ulcers or multiple ulcers are seen over the length of the small intestine. So he is strictly advised to stick on to a very bland type of diet, so that these ulcerations might not lead to complication as to be might go into perforation. That should not happen. So the person is that's why avoided was restricted or is he strictly informed to avoid spicy spicy food and take a bland diet so that the complication related to the ulceration can be prevented and the healing also happens naturally. Whereas that is our type. But now if you compare the tuberculosis, if tuberculosis, if a person suffers from tuberculosis related to the GI tract, can make out the ulceration. So here it is a vertically located and oval, whereas you can make out here, so it is a transversely located. So one of the again complication related which is seen in the tuberculosis but not seen in typhoid would be, so based upon the presence, now it is since it is transversely present, so when the ulcer heals in tuberculosis, so every chance is that because of fibrosis it might lead to formation of narrowing of the stricture of the constriction, is a term called strictures or constriction. So because of fibrous tissue formation after the healing of the ulcer, so it might lead to formation of strictures around all along the length of the small intestine, causing again obstruction in the process of propagation of peristalsis. So that is the characteristic feature which is seen in tuberculosis of the GI, but is not a complication not to be seen in the typhoid fever. So there is also differentiation between the typhoid fever ulcers as well as the tuberculosis ulcer. So that is how the upper aspect related to the jejunum and the ileum. Now we look at the blood supply of the jejunum and the ileum. So the blood supply is as it is very much evident from the diagram over here. So this is one of the branch of the abdominal aorta, so that is the superior mesenteric artery. So superior mesenteric artery gives rise to, as you can make out over here, these are the quite a long jejunal branches and ileal branches. So both jejunal and ileal branches, they supply they arise from the superior mesenteric artery and supply the coils of the jejunum and the ileum, so which are almost about 12 to 15 in number approximately, so that value and that number might vary slightly. Whereas venous drainage, the veins accompany the branches of the same name and ultimately drain into a larger vein, that is the superior mesenteric vein. So that is how the arterial supply and venous drainage can be mentioned. Whereas the lymphatic drainage will drain the lymph from this coils of the small intestine, particularly it is said to be draining into a superior group of superior mesenteric group of lymph nodes around the superior mesenteric vein and artery. So there will be a lymph nodes, group of lymph nodes. So those lymph nodes will receive the lymph from the coils of the small intestine, that is jejunum and ileum. But this is one diagram again to make you understand again related to the difference exact difference between jejunum and ileum with respect to the arrangement of the vessels on the artery that is supplying the jejunum and ileum. Now, if you take up, if you observe this one, considered to be a coil of the jejunum. Now, if you look at this diagram, now the superior mesenteric artery giving rise to the jejunal branches. Now, jejunal branches they are forming an arcade pattern, network pattern over here, arcade or arch-like or network pattern over here. So, this is called as an arterial arcade. Now, there is usually one or maybe two rows of arterial arcade pattern seen in the jejunum, whereas now the branches arising from the arterial pattern or the arterial arcade can make out here, they are called as vasa. Then the straighter branches that they are arising, so they are called as recta. That is straighter. Recta means the straighter appearance. So vasa, recta. So these two features. So one, you make it out here with respect to jejunum, there is an arterial pattern in the form of arch that is called arterial arcade. So it might be one or maybe two rows, whereas the branches arising from the arterial arcade is called as, those branches are called as vasa recta. Now the thing is, the vasa recta are quite longer. So arterial arcade is one or two maybe, whereas the vasa recta are quite longer. So that is the characteristic feature of the jejunum. Whereas if you compare it with the ileum over here, now as you can make out here, same superior mesenteric artery giving rise to branches called as the ileum branches. Now look at the arterial pattern. So arcade like a arch-like pattern. So that is almost about 4 or maybe 5 rows. Here it was just 1 or maybe 2 rows of arterial arcade pattern. The same pattern is almost about 4 or maybe 5 rows of arterial arcade. That is again the characteristic of ileum. Now look at the vasa recti. So here they are quite longer. Now they are comparatively quite short. So because of multiple rows over here, so vasa recti appear to be quite shorter compared to this one. So that is the classical difference between the jejunum when you are locating the meaning of jejunum and ileum. So this you have to keep it in mind. So arterial arcade pattern and the vasa recta. So here it is 1 or 2 rows and the vasa recta are quite longer. So there are 4 or 5 rows of arterial arcade pattern and the vasa recta are quite shorter compared to the jejunum. That is the characteristic difference between the jejunum and ileum. And as well as we can make out the circular folds that we saw earlier as a modification or feature of the mucosa or the folds or the walls of the cartilage or circular folds. So they are considered to be larger and very closely or densely packed, whereas the same circular folds are considered to be shorter and not that dense as compared to that of the jejunum over here. So that is again one of the difference. Apart from that, these you can usually we make out solitary lymph nodes which can be seen to be stretching all over the length of this jejunum, whereas as you go towards ileum, if you remember, as you go towards ileum, the Peyer's patches become very prominent. So or the lymphatic aggregation increases in number because it has an immunity. So over in the ileum, because we are going towards the large intestine, which is nothing but consisting of the undigested food over there. So that is how the immunity is better or much more important in the ileum region. So that is how the difference of. So that is how we can maintain the represent the difference between the jejunum and the ileum. Whereas nerve supply consists of autonomic nerve supply, sympathetic and parasympathetic. Sympathetic will be from the lower segment, thoracic segment of the spinal cord, and functionally they are considered to be motor to the gut sphincter. So motor to the gut sphincter. Whereas exactly opposite what we see to be the role of the parasympathetic branch arising from the vagus nerve. So the function of the parasympathetic fibers would be mainly to stimulate the propagation of the modulated intestine in the form of peristalsis, and it is obviously inhibitory to the sphincters over there. So that facilitates further propagation and dilation. That is the difference between the sympathetic and parasympathetic nerve supply to the small intestine, that is the jejunum and ileum. So that is about between the two parts of the small intestine. Now we look into a small chapter related to the fold of the peritoneum. That is coils of the small intestine. Now this mesentery is considered to be. This diagram is a can make out this line, this oblique line represents the being attached to the posterior abdominal wall. It has a root of the mesentery. The other feature would be the free or the intestinal margin of the border. So you can say either two margins or two borders. One would be root of the mesentery. The second is called as the intestinal margin of the border of the mesentery. Now, what exactly the root dimension wise? Both of them there is a very evident differentiation. So the root length almost about 6 inches, just about 15 centimeters long. So the root of the mesentery is 15 centimeters long. It is a point where it is attached to the posterior wall, whereas the free border is the one that will surround the walls of the intestine and suspend. So that is almost 6 meters or 20 feet, approximately 20 feet long. So that is how the difference between the root and the free or the intestinal margins or the borders of the mesentery can be known or kept in mind. So remind you, it is just the root is 15 centimeters long, whereas it is 20 feet longer. So difference between the root and the free or the intestinal margin of the mesentery. So those things are. Now we'll slightly look into the fewer details related to each of the two features of the mesentery. So one, if you take up the root, this diagram here. So root, as I said, comes in this one. So you have even seen the earlier thing. This represents the root of the mesentery. This obliquely present line that you are seeing over here. So this represents the root of the mesentery. You have even seen. If you go back to the earlier image of this part as a surface marking view. So this is where the root of the attached margin of the mesentery can be made out. To be present, remember, to be present obliquely. It is not vertical or transverse. It is obliquely present. So the root of the mesentery is obliquely present, and it is attached to the posterior abdominal wall. Now, it extends from where to where? The root extends from where to where? So, extends from duodenojejunal flexure to the iliocecal junction. So, we already know that the coils of the small intestine, that is with respect to jejunum and ileum, it extends from duodenojejunal flexure to the iliocecal junction. So, that is where the root of the mesentery is obliquely present, extends between these 2 points. Now, if you wish to describe the location of the duodenojejunal flexure and iliocecal junction with respect to the bone or osteology, so they say that what happens is duodenojejunal flexure will present almost just left of slightly left to the second lumbar vertebra. So the location of the duodenojejunal flexure will be just to the left of the midline at the level of the second lumbar vertebra, whereas with respect to the iliocecal junction, so its location is around the right sacroiliac joint, the level of the right sacroiliac joint. So that is how the location with respect to or relation of the two ends of the root of the mesentery, relation of the two ends of the root of the mesentery with respect to bone. So this is just left to the midline at the level of the second lumbar. This is at the level of the right sacroiliac joint. It will be at the level of right sacroiliac joint. That is how can mention it as the extent, the oblique extent of the root of the mesentery. Now this root of the mesentery crosses certain structures. Now the structures, this can be a individually defined marker, or it can be asked as structures the mesentery as a free marker, structures caused by the root of the mesentery. So what are the structures the root of the mesentery comes in contact with while being attached to the posterior abdominal wall? So as it enumerated in the image itself, as you can make out here, so this will be the duodenum, first, second, and the third part of the transverse part of the duodenum. So it will pass or is in contact with the structures that crosses the mesentery would be the third part of the duodenum, also called the horizontal part. And further as you go down, this is the abdominal aorta. You can see over abdominal aorta, and further down inferior vena cava, and further as you go towards the the structures which are crossed by the root of the mesentery above and onwards, third part of the duodenum, the abdominal aorta, inferior vena cava. As you go down, right gonadal vessels, then the right ureter, and the psoas right psoas muscle. So those are the structures crossed by the root of the mesentery. Same thing as we have seen over there. So those are the can be a 3-mark individually separate structures crossed by the root of the mesentery can be separated 3-mark portion as well. Now the other border of the mesentery would be the free or the intestinal border. So obviously, as you can make out here, so there is one free border. So the root has been cut over here. You can make out this entire is the mesentery over here. So this one, that is the one you can make out the boils of the small intestine. So they are being suspended by the mesentery. So this is the mesentery, the fold of the peritoneum along with the yellowish tinge or discoloration, coloration that is representing the fat represented along the mesentery. So these are the coils of the small intestine. So these coils of the small intestine, they are suspended by the free border of the intestinal border of the mesentery. So main function would be the functional aspect is to permit free motility at the loop of the intestines for better digestion and absorption function of the coils of the small intestine. So you can make out over here. So this part is the mesentery. This is the free or the intestinal margin. So these are representing the coils of the small intestine. So that represents the two borders. There is a attached and the free border. What exactly the mesentery as such consists of? So we have seen already. So to be seen fat deposition, quite obvious. Now, if you further observe, the fat diminishes from towards the root, it goes towards from this region. The fat slightly decreases as you come towards the intestinal border. Right? Comparatively, the fat will be more over here as it is compared to the free or intestinal border. So that's what they describe it. So the amount of fat is slightly lesser from compared to the root to the intestinal border. So slightly lesser, so slightly reduces, slightly diminishes. Whereas if you look at the contents in the mesentery, so structures crossed by the mesentery can be 3-marker, contents within the mesentery again can be a 3-marker question. So what are the contents within the mesentery? As you can make out here, this is the mesentery. What you are seeing, you see these blue and reddish lines representing the superior branches of the superior and the mesenteric artery and the vein, tributaries of the vein and the artery branches, superior mesenteric artery and vein. Now there will be these what branches, specifically jugular and ileal branches of the artery and the vein. So that is the one which will be seen more as a content in the mesentery. Apart from that, there will be various lymphatics and the lymph nodes as well. Now the lymphatics and lymph nodes, so they are almost about approximately they say about 100 to 200 lymph nodes are to be seen in the mesentery. And there will be aromatic plexus of the nerves, and as obvious, the kinetic tissue and the fat, which we have already seen, which gives a yellowish tinge, and the kinetic tissue, and what obvious, the most important as a component of the mesentery would be the coils of the duodenum and ileum. So that is how the contents of the mesentery can be described. So that is about the mesentery as well. Can be 5-marker or can be a 3-marker. In other ways, it can also be asked in both of the ways. Now the last on the list would be the upper aspect. Now since being suspended from the having a can say mobility, free mobility because of suspending from the mesentery. So it equally has a part of gives a part of vulnerability as well. So because of free suspension, any chances that it might protrude contents of the intestine, contents of the mesentery can protrude through these the vulnerable points within the anterabdominal wall, as we have already seen with respect to the inguinal canal or the femoral canal causing hernias respectively. So that is also one of the features, as a common feature. Whereas even the group of as we already know as a content, there are quite a number of hundreds of lymph nodes within the mesentery. So any infection infected lymph node can increase in side inflammatory wise because of inflammation, and it can adhere to the wall of the small intestine, giving rise to mechanical obstruction. That is the second aspect. And the third would be like it might be difficult at certain times to differentiate between acute mesenteric lymphadenitis to the acute appendicitis. So both of them almost more or less the features might overlap. So relatively we have to differentiate between these two conditions. So those are the other aspects that is this one, that is the masonry. Now that is about these two topics today. So now that is about difference between judgment and idea. Last but not the least would be before any the MCQ related to this topic. One question would be like the incorrect statement of the about the judgment would be what is the incorrect respect to judgment. So forms according to the first understand this is correct. Beginnings are done, this is also correct, and recently presents windows. So windows, what does this mean actually? So the fact the spaces, because of less amount of fat, so there appears to be transparent translucent appearance in the mesentery. So those are called as windows. So mesentery presents windows in case of jejunum, whereas an idiom, because of excess amount of fat, more amount of fat in the mesentery, so those windows of the translucent areas in the mesentery might not be visible in the idiom. So there is a difference. Windows are nothing but translucency because of amount of fat. So it is seen as jejunum and not. It has more pairs present than idiom. Obviously it is wrong because incorrect statement because idiom has more number of pairs patches that is seen. Whereas the second question is all are correct regarding the idiom. So with respect to idiom, so we already know forms the lower 3/5 of the understand. This longer part, it is correct. Terminates at idiomatic adjunction, that is also correct. And recently does not present windows, that is also correct with respect to that recently. Windows are best seen in the jejunum, but not that prominent in the idiom. So that is what. And what is the incorrect statement about here is proximal part has maximum concentration of the base mass. That is again very wrong because this is incorrect in the sense, especially the distal part has of the idiom has a maximum concentration of base mass rather than the proximal distal part, because we are going more towards we are getting closer towards the larger intestine. So distal part may have more concentration of base mass compared to the proximal part. So that is all incorrect statement. The third question is the root of the mesentery possible following structures. What are the structures caused by the left quadrant, third quadrant neuron? This is correct. Right one is correct. Including the neuron, this is also correct. What is not correct is the left quadrant. This is not caused by it. The fourth incorrect about the free intestinal border is, so free border of the mesentery is 6 meters long. So free border. The neck permits the free mobility of the loops of the jejunum and idiom in the abdominal cavity. Fat deposition is uniformly seen throughout the mesentery, but it is not. So it is not uniformly, as you have already seen that fat deposition as it goes towards the intestinal border slightly becomes lesser, diminishes. So that is an incorrect statement over here. So that is all incorrect. Now this image, what part of the wall of the intestine? So this nanomembrane submucosal layer of the small intestine. So that is about one more MCQ. So which is incorrect about the idiom. So wall of the idiom is thinner, lumen is narrower, lumen is wider, and has 4 of the arteries. So what is incorrect is lumen wider. When you go to the diameter form, you get an idea. Lumen of the idiom is narrower compared to the jejunum. So that is all. So that is about this topic. Thank you very much.
Good morning to all. Today we'll start our physiology of equilibrium. Before we start, I'll call up the numbers. Please give a attendance. If you give, then only you will get a attendance. Roll number 3, roll number 14, 24, 27, 30, 44, 45, 58, 59, 70, 74, 86, 88, 98, 105, 108, 114, 124, 138, 143, 146. Please give attendance. Now we'll start a class. As you know, this physiology of equilibrium, little bit you have already read in the CNS part. The specific learning objectives for the topic is enumerate and describe the structures constituting the vestibular apparatus. Why vestibular apparatus? This is the one which maintains the posture and equilibrium. Describe the neuronal connections of vestibular apparatus with the central nervous system. List the functions of vestibular apparatus. Enumerate the clinical disorders associated with vestibular apparatus and the tests that are performed in suspected case of a vestibular dysfunction. Coming to the topic, vestibular apparatus is a part of inner ear. During doing a special senses in the ear, we also told about vestibular apparatus. Even this little bit you are read in the CNS part also. So it plays an important role in the maintaining posture and equilibrium through statokinetic reflexes. Labyrinth or inner ear consisting of two structures. One is bony labyrinth, second one is a membranous labyrinth. So bony labyrinth is a series of cavities or channels present in the pittress part of the temporal bone. Membranous labyrinth is situated inside this bony labyrinth. The space between these two bony and membranous labyrinth is filled with a fluid called perilymph, is also called as a periodic fluid. So this fluid, that is perilymph, is similar to the ECF in composition with large amount of sodium ions. This is a diagram showing a bony labyrinth is this yellow color part. The inside blue one is a membranous labyrinth. In between these two bony and a membranous labyrinth, there is a perilymph. This is a diagram of vestibular apparatus. Coming to the membranous labyrinth, it is formed by the membranous tubules and sacs. It is consisting of two portions. One is cochlea, which is concerned with sensation of hearing. Second is vestibular apparatus, which is concerned with posture and equilibrium. Membranous labyrinth is filled with a fluid called endolymph. In between bony and membranous labyrinth, it is perilymph. In membranous labyrinth, it is endolymph or otic fluid. There it is periotic fluid. Endolymph is similar to the ICF, whereas the perilymph is similar to the ECF. It has a large quantity of potassium ions, where the perilymph has a large quantity of sodium ions. This is cochlea. This is semicircular canals, utricle and saccule. These are the two parts of membranous labyrinth, cochlea and the vestibular apparatus. Coming to functional anatomy of vestibular apparatus. This is formed by the three semicircular canals and otolic organ or a vestibule. Semicircular canals are tubular structures which are placed right angles to each other. These are the three semicircular canals. This is the one which is called as the anterior semicircular canal. This is posterior semicircular canal, and this is the third one, lateral semicircular canal. These canals are placed right angles to each other. Because of this type of arrangement, that is right angles to each other, the semicircular canal, that is vertical, anterior, posterior and transverse axis, they are named as anterior canal, posterior canal and lateral or the horizontal canal. Anterior and posterior are situated vertically and lateral canal is situated horizontally, plane. Okay. Then coming to ampulla. Ampulla, there are two ends for this semicircular canal. See, this is a one end, this is a second end. Two ends for each semicircular canal. One end is narrow and one end is enlarged. The enlarged part is called as enlarged part of a semicircular canal is called as an ampulla. This ampulla contains a receptor organ for a semicircular canal known as a crista ampullaris. So ampulla of the all three canals are narrow end of horizontal canal open directly into the utricle. See, narrow end they open directly into the utricle. This is the utricle. The narrow ends of anterior and a posterior canal, they fuse together to form a common crest. Thus, all the three canals open into the utricle by 5 openings. See, anterior and a posterior combined to form a common crest is one. This is the second one, third, fourth and a fifth one. These are the 5 openings of a semicircular canal into the utricle. Utricle then opens into the saccule. This is a saccule. Coming to otolith organ or a vestibule. Till now you have read about the semicircular canals. Now it is otolith organ. Otolith organ is formed by the utricle and a saccule. Together it is called as a otolith organ. Often these are together also called as otoliths. So utricle communicates with the saccule through the name utriculosaccular duct. Then the saccule communicates with the cochlear duct through ductus reunions. Okay. Another duct called endolymphatic duct arises from the utriculosaccular duct. It ends in a bag-like structure called endolymphatic sac, which lies on the cranial surface of the petrous bone. See, this is a endolymphatic sac. This is a utricle saccule. This is a continuation of a cochlear part. Coming to the receptor organ which is present in the vestibular apparatus. The receptor organ in the semicircular canal is called crista ampullaris, and that in the otolith organ, that is otolith organ is utricle and a saccule. The receptor organ is macula. So you should remember crista ampullaris is for semicircular canal, macula is for otolith organ, that is utricle and a saccule. This receptors organ contains the proprioceptors. This regarding proprioceptors you have read in theory and in practicals. That is these receptors which respond for a movement of a joint. Coming to the receptor organ present in the semicircular canal, that is crista ampullaris. Crista ampullaris is a crest-like structure situated inside the ampulla, that is dilated part of the semicircular canal. The crest is formed by the receptor epithelium. This is a receptor epithelium which is called as a neuroepithelium, which consisting of a hair cell, these are the hair cells, then supporting cells and secreting epithelial cells. Hair cells, supporting cells and a secreting epithelial cells. The secreting epithelial cells will secrete the proteoglycan. These cells are arranged in a planum semilunatum. There is a group of epithelium. This is a planum semilunatum. They are arranged in the form of group of epithelial cells around the hair cells. These are the cells in the crista ampullaris. Now we will see what are the hair cells. This is the same diagram in another book, that is crista ampullaris. The hair cells of the other receptors cells in the crista ampullaris. There are two types of hair cells, type 1 and type 2 hair cell. Hair cell of the semicircular canals, utricle and saccule receive both the afferent and efferent nerve terminals. Now we will see what are the types of how they look. Type 1 hair cell are a flower shaped cells. Afferent nerve terminate in the form of calyx. In type 1 hair cell, there is a nerve calyx where the afferent nerve ending will terminate, whereas the efferent nerve ends on the surface of the calyx. Efferent nerve will end on the surface of the calyx, whereas the afferent will terminate in the form of a calyx around the type 1 hair cell. This hair cell has a stereocilia and kinocilium. Coming to type 2 hair cell. Type 2 are cylindrical shape or a test tube shape. Both afferent and efferent are present here, but both are end at the surface of the cell body without forming a calyx. Here calyx is present in the type 1 hair cell. Type 2 there is no calyx. This is a flat shaped cell. Is a cylindrical or a test tube shaped cell without a calyx. Cilia of a hair cells, apex of each other cell has a cuticular plates here. So this is regarding the hair cell. From this plate about 40 to 60 cilia will arise, which are called as a stereocilia. Each stereocilia are attached to its tip to the neighboring taller ones one by means of a tip link. Stereocilia attached to the neighboring ones with a links called a tip link, which is important for a transmission of a mechanotransduction, that is a transmission of a production of a action potential. Because of the tip links, all the stereocilia are held together. One of the cilia is longer, a tall, which is named as a kinocilium. The tall one is a kinocilium, short one is a stereocilium. Next, coming to cupula. This till now we have read about hair cells, supporting cells and the plana semilunatum. Coming to cupula. Cupula from the crista ampullaris, a dome-shaped gelatinous structure extend up to the roof of a ampulla known as a cupula. This cupula cilia of a hair cell which are present in the neuroepithelium are projected into the cupula. Okay, this is a cupula where the cilia of the hair cell will project into the cupula. Till now you have read about the receptor cell of a semicircular canal, that is crista ampullaris. Now we will read about a receptor organ in otolic organ, that is utricle and sacula, that is macula. Receptor organ, otolic organ is called macula, like crista ampullaris. Macula is also formed by the neuroepithelium and the supporting cells. Even these are the same hair cell, type 1 and type 2 hair cell. This is a diagram showing a macula, that is a receptor organ in the utricle, which are horizontally placed. This horizontal is with respect to the otolic membrane. This otolic membrane is horizontally placed. The hair cells are attached to the cilia of the hair cell attached to the otolic membrane, whereas the macula of saccule are vertically placed. Cilia are attached to the otolic membrane. This is the receptor organ for a otolic organ. Coming to otolic membrane. What is this otolic membrane? Like a crista ampulla, this macula is also covered by a gelatinous material called otolic membrane. It is a flat structure, not dome-shaped structure like a cupola. The stereocilia and kinocilium of each hair cell is embedded in the otolith membrane. The otolith membrane contains some crystals which called iridescent or otoconia or statoconia. Otoconia is mainly constituted by the calcium carbonate. Okay, this is the otolith membrane. Coming to the situation of a macula, where they are placed. In macula in utricle, the macula is situated horizontal plane so that the cilia of the hair cell are in vertical direction. Here otolith membrane is in horizontal plane and cilia of the hair cell are in a vertical direction. Macula in saccule. In case of a saccule, it is vertically placed otolith membrane. The cilia are horizontally in direction. Okay, this is the site where the macula is present in the utricle and the saccule. Coming to this, till now you have read about the receptor organ in the semicircular canal and in the otolith organ. Semicircular canal, it is a crista ampullaris. In otolith, it is a macula in the otolith organ. Coming to nerve supply of a vestibular apparatus. Impulses from the hair cells of crista ampullaris and the maculae are transmitted to the medulla oblongata and other part of the CNS through the fibers of vestibular division of a 8th cranial nerve, that is vestibulocochlear nerve. Now we will see the first order, which are the first order, second order and the third order neurons of this vestibular apparatus. The first order neurons of the sensory pathways bipolar cells. The soma, that is the head of the bipolar cell, soma of the bipolar cells are present in the vestibular, which is situated in the inner auditory meatus. The dendrites of this bipolar cells reach the receptor organs, that is crista ampullaris and maculae in the vestibular apparatus. The branches of these dendrites have a close contact with the basal part of the hair cell. Dendrites of the bipolar cells terminate in the type 1 hair cell, comparatively larger than those of the type 2 hair cell. Axons of the first order neuron, that is a bipolar cell from the vestibular division of the vestibulocochlear nerve. These fibers will reach the medulla oblongata and terminate in the vestibular nuclei. So these are the primary vestibular fibers. We will see in the diagram. These are from the utricle and the saccule, semicircular canals. They reach the vestibular ganglion. From the ganglion, it reaches a vestibular nuclei. Vestibular nuclei are a set of 4 nucleus. One is superior nucleus, medial nucleus, inferior nucleus and a lateral nucleus. Coming to vestibular nuclei. As I told, it has a 4 nuclei. One is superior, inferior, medial and a lateral nuclei. Most of the primary vestibular fibers reaching the superior and the medial nuclei come from a crista ampullaris of the semicircular canal. Lateral vestibular nuclei receives the fibers from the macula of the otolith organ. Inferior one receives from both the crista and the maculae. So, superior and the medial receives from the crista ampullaris. Lateral one will be received by the macula of the otolith organs. Inferior one receives from both the sides, that is crista and the crista ampullaris and from the maculae. So this is the vestibular nuclei of the 4 cells: superior, inferior, medial and lateral nuclei of a vestibular nuclei. Okay. That is regarding the vestibular nuclei. First order neuron is here, vestibular nuclei. Then coming to fibers to cerebellum. Fibers from some bipolar cells will reach the cerebellum directly and terminate in the flocculonodular lobe or the vestigial nucleus of the cerebellum. This is regarding a first order neuron. Coming to second order neuron. Second order neuron is from a 4 nucleus of the vestibular nuclei. Axons of the vestibular nuclei form the secondary vestibular fibers. This secondary vestibular fibers has the 4 tracts: vestibulo-ocular tract, vestibulospinal tract, vestibulo-reticular tract and vestibulocerebellar tract. First one we will see what is vestibulo-ocular tract. The fibers from superior and medial inferior fibers, they descend downwards. Superior, medial and inferior, they descend down for a short distance with the vestibulospinal tract. Afterwards, these fibers ascend through the medial longitudinal fasciculus, terminate in the 3, 4, 6 cranial nerves, thus forming the vestibulo-ocular tract. From superior, medial, inferior nucleus, vestibular nucleus, they descend down along with the vestibulospinal tract. Again they ascend with the medial longitudinal fasciculus to terminate in the 3, 4 and 6 cranial nerve, forming the vestibulo-ocular tract. This tract is concerned with the, because it has contact with these 3 nerves which supplies the eye, movement of the eyeball in relation to the position of the head is the function of this tract, vestibulo-ocular tract. Coming to vestibulospinal tract, fibers from lateral descend downwards to form the vestibulospinal tract. Some fibers from this nucleus ascend and join the medial longitudinal fasciculus. Fibers from the vestibulospinal tract involved in the reflex of movement of head and body during postural changes. All these 4 tracts has a individual function. Coming to vestibulo-reticular tract. Vestibulo-reticular tract, fibers from vestibular nuclei reach the reticular formation of brainstem, forming a reticulospinal tract. These fibers are concerned with the facilitation of muscle tone, maintenance of muscle tone. Coming to vestibulocerebellar tract. Some fibers arising from all 4 vestibular nucleus terminate in the flocculonodular lobe or a vestigial nuclei of cerebellum. This tract has a function of coordination. Cerebellum is known for a coordination movements according to the body posture. Is vestibulocerebellar tract function. This regarding the nerve supply of a vestibular apparatus. Coming to functions. What are the functions of vestibular apparatus? Because the presence of these receptors, semicircular canal give response to rotatory movements of the angular acceleration of the head. Receptor of a utricle and a saccule gives response to linear acceleration of the head. Thus, the vestibular apparatus is responsible for detecting the position of the head during the different movements. It also causes reflex adjustment in position to eyeball, head, body during the postural changes. These are the function of vestibular apparatus. In particular, the function of semicircular canal is for a concern with the angular or rotatory acceleration. Semicircular canal sense the rotation movement. Each canal is sensitive for a rotation in particular plane. Say example, superior semicircular canal gives response to rotation in anterior-posterior plane, that is transverse axis. Front to back movement like nodding of head while saying yes. This is for the example, it is a front to back movement. This superior semicircular canal will get activated. That is, this is going to sense the movement. That is nodding a head while saying a yes. Coming to second one. Horizontal semicircular canal gives response to rotation in horizontal plane, that is vertical axis, that is side to side movement, left to right or right to left, like shaking of a head for saying no no. Okay, this is for a horizontal semicircular canal. Coming to posterior semicircular canal gives response to rotation in vertical plane and anterior posterior axis by which head is rotated from shoulder to shoulder movement. This posterior semicircular will receive a movements. Coming to mechanism of how the receptors will stimulated in the semicircular canal. At the beginning of rotation, these receptors always active during the beginning and at the end. Throughout a continuous movement, constant speed, these receptors are not activated. So at the beginning of rotation, receptor cells are stimulated by the movement of endolymph inside the semicircular canal. However, the receptors are stimulated only at the beginning and at the stoppage of the rotatory movements. During the rotation at a constant speed, these receptors are not stimulated. You should remember only at the beginning and the stoppage. At the constant speed, these receptors are not activated. Say example, when a person rotates in a clockwise direction in horizontal plane, horizontal canal moves in a clockwise direction, but there is no corresponding movement of endolymph inside the canal at the beginning of the rotation, because this is the inertia offered by the endolymph which remains static. The phenomena causes relative displacement of endolymph in direction opposite to that of the rotation of the head. Initially there is no movement because of the accumulation of the endolymph or the inertia offered by the endolymph, but little later the endolymph moves opposite to that of the rotation of the head, that is the fluid pushed in the anti-clockwise direction. This is a diagram showing that in the right horizontal semicircular canal, the endolymph flows towards the ampulla. This ampulla, dilated part is the ampulla, flows towards the ampulla. In the left, it is the fluid moves away from the ampulla. The head is moving the clockwise direction, but the initial stage the fluid is moving in opposite direction, that is in the anti-clockwise direction. So this is excited because this is the endolymph is moving towards the ampulla. In the ampulla we have the receptor cells to get activated by the movement of the fluid, but in left one it is moving away, because of which there is no excitation of the receptors. This is another diagram which explains in detail. This is at rest, left semicircular canal, right semicircular canal. These are the ampulla part which contain the receptors. This is a tall hair cell, that is kinocilium, stereocilia. So in starting, direction of movement of the head towards the right. If there is a movement of the head towards the right, what happens? The fluid moves in the opposite direction, that is towards the ampulla. Because of movement of the fluid towards the ampulla, the receptors in the ampulla get activated. The stereocilia moves towards the kinocilia. Always the movement of stereocilia towards the kinocilium is the one which stimulates or generates the action potential or stimulation of the hair cell. But in the left side, the fluid is moved away from the ampulla, because of which the stereocilia also moves away from the kinocilia. That is the inhibition is by hyperpolarization. Here in the ear, stimulation is by depolarization, inhibition is by hyperpolarization. This is another diagram with a continued movement at a constant speed. This is the initial stage, this diagram. Second one is with a continued movement at a constant speed, movement of the head and movement of the endolymph in the same direction. Initially it is in the opposite direction, but at a constant movement it is in the same direction. at the same speed, so the ampulla is not affected. But during the stoppage or the cessation of the movement, the head and the endoleaf continues to move and cause the movement of the cupula away from the ampulla, and towards the left it is towards the ampulla, because of which there is a towards the left in the semicircular, in the horizontal semicircular canal. So here it is hyperpolarization in the right side, left side the horizontal canal and the receptors are activated in the left side in the D diagram. Okay, this is the examples for the movement of a head, how the movement of fluid occurs when the head moves on one side. In the initial stage, it is in the opposite direction of the movement of the fluid with the movement of the head, because of which the activation or the stimulation of the hair cell leading to depolarization. At the cessation, it is in the movement in the opposite direction, in the opposite semicircular canal. They move in the opposite direction, leading to the activation of the other side hair cell. The same side will be hyperpolarized or the stoppage of a stimulation of the hair cell. Okay, because of stimulation of the hair cell in the right horizontal canal, send information through the sensory nerve fibers to the vestibulocerebellar or the reticular centers. Now these centers send proper instruction to the various muscles of the body to maintain the equilibrium of the body during angular acceleration or the rotation of the head. This is regarding the movement of the what happens when the head moves to the different sides. Coming to the electric potential in the hair cell, how the action potential will generate in the hair cell. First, mechanotransduction. Mechano, that is a movement, will convert into the action electric potential. Mechanotransduction is a type of a sensory transduction in the hair cell, which is a receptor by which a mechanical energy or a movement of cilia in a hair cell caused by stimulation converted into the action potential in the vestibular nerve fibers. The resting membrane potentials in the hair cell is -60 millivolts. Movement of stereocilia of a hair cell towards the kinocilium causes opening of mechanical gated potassium channels, followed by influx of potassium ion from endolymph, which contains a large amount of potassium ions. This is a diagram showing the movements, that is stereocilia moving is a resting state. When the stereocilia move towards a kinocilium, there is a tall bar, the opening of a potassium channel along with the potassium is a tip links. Along with the potassium channel, calcium also will enter inside. Then the action potential will generate. After this, to inhibit the generation of action potential, the myosin chain which hyperpolarizes or closes the potassium channels in the kinocilium, leading to hyperpolarization or a stopping of a generation of a action potential in the hair cell. The molecular motor, that is myosin base, present in the higher neighboring process next to the moves the channel towards the base and thereby releasing tension in the tip link, which causes a closure of a mechanosensitive potassium channel, permits restoration of the resting state. The depolarization of the hair cell causes a release of a neurotransmitter, which is called as a glutamate, which initiates the depolarization of a neighboring afferent neurons, causes generation of a action potential. Movement of stereocilia in opposite direction causes hyperpolarization. As I told, the stereocilia moving away from the kinocilia causes hyperpolarization. Calcium may move along the development of hyperpolarization, stops generation of action potential in the nerve fibers. Okay, this is a diagram showing when the stereocilia move towards the kinocilia, it is an activated hair cell. When they move away from the Kinocilium is a deactivated or hyperpolarization or the stoppage of generation of the action potential in the hair cell. This is a resting state, is activated, and this is a deactivated state of the hair cell. Okay, this is regarding the stimulation of the production of a action potential in the nerve fibers. Coming to adaptation of the receptors in semicircular canal during rotation. Hair cell of the crista ampullaris generate impulses even at rest, but the frequency of discharge is very low compared to the during the active stage. It is about 50 to 100 impulses per minute during rest. At the commencement of a rotation, when once a rotation starts, the discharges will be around 600 to 800 per minute depending upon the speed of the rotation of the head. However, the rapid discharge of the impulses lasts for about 20 to 25 seconds of rotation. Afterwards, even the rotation continues, the frequency falls back to the resting state. It is because due to the adaptation of the receptors for the continuous movement of the rotation. As I told in the previous slides, at the beginning and at the end of the stoppage of the movement, the receptors will get activated, but the constant movement will not stimulate the receptor to activate. This is the same thing at the onset of rotation. Endolymph inside the semicircular canal doesn't move along with the semicircular canal. This is because the inertia of the fluid which causes a stimulation of the air cell. After 20 seconds, due to the accumulation of the air cell, a pressure develops in the ampulla which causes the adaptation of these receptor cells. This is regarding the function of semicircular canal. Then coming to function of otolic organ, that is utricle and a saccule. Semicircular canal is for a rotational movement, whereas the otolic organ is for a linear acceleration, detects acceleration both the horizontal and in the vertical plane. Utricle responds for a horizontal acceleration, saccule is for a vertical acceleration. Then role of otolic organ in resting position. During resting condition, hair cells are stimulated continuously because of the pulling of otoconia by gravitational force. Stimulation of the air cell produces reflex movement of head and the limb for the maintenance of posture in relation to gravity. Because of this function, these receptors are also called as a gravity receptors. This is regarding the function of semicircular canal and the otolic organ. Coming to effect of stimulation of semicircular canal. We can stimulate semicircular canal by two mechanisms. One is rotational movement, second is caloric stimulation. What is the rotational movement? The rotational movement is by using a Barrini chair. What is this Barrini chair? It is a revolving chair. The subject is seated on this chair with the head tilted forward at a 30 degree, both the eyes closed. So, the chair is rotated at a speed of 30 revolutions per minute for about 20 seconds and then it is stopped. So, effects are seen here. Canals by rotation, stimulation of the semicircular canal during rotation will produce some reactions after 20 seconds of stoppage of a rotation. The following reactions are seen. One is post-rotatory nystagmus, dizziness, vertigo and other effects like for longer causes nausea and vomiting. And blood pressure also falls about 10 to 15 mm per Hg. Then heart rate also reduced by 10 to 12 beats per minute. Reaction during rotation with opened eye. This is during a closed eye. Then when the eye opened with a rotation, what happens? Nystagmus occur continuously throughout a period of a rotation. This is regarding a rotational stimulation. Next is caloric stimulation. This can be stimulated by bypassing hot or cold water into the ear by using a syringe. The transmission of change in temperature into labyrinth alters the specific gravity of a endolymph. This in turn causes movement of cupula and stimulation of the receptors, that is syringing with the hot or cold water into the ear, transmission of a temperature into the labyrinth which alters the specific gravity, because it is already having the specific gravity. When you enter the extra fluid, it alters the specific gravity of the endolymph, which in turn causes the movement of cupula. That is, cupula is a part of crista ampullaris, which is a receptor of semicircular canal, stimulates the receptor cells. What happens? The stimulation of this semicircular canal by thermal stimulus develops nystagmus, vertigo and nausea. This is a test for a testing semicircular canal. One is by rotational movement by using a Baroni chair. Second is by caloric stimulation. Coming to the applied aspect of labyrinth vestibular apparatus. First is effect of labyrinthectomy. When you do bilateral, both the sides labyrinth is removed. Removal of labyrinthine apparatus, both the sides lead to complete loss of equilibrium, because bilaterally the vestibular apparatus is removed. Equilibrium couldn't be maintained only by the visual sensation. Postural reflexes are severely affected by bilateral labyrinthectomy. Then coming to unilateral labyrinthectomy, that is removal of labyrinthine apparatus on one side, causes less effect on postural reflexes. In this, it is postural reflexes are severely affected because of bilateral labyrinthectomy. In unilateral, it has a less effect on postural reflexes. However, severe effect on autonomic symptoms will occur. Unilateral labyrinthectomy. These autonomic symptoms are severe due to unbalanced generation of impulses from the unaffected labyrinthine apparatus. Because if you remove one side, the other side will produce the action potential. It is difficult to control the impulses from the normal labyrinthine apparatus of the other side. The symptoms of the unilateral labyrinthectomy are nausea, vomiting and diarrhea. This is regarding a unilateral and a bilateral labyrinthectomy. Coming to motion sickness. This motion sickness you have already read in the vomiting in CNS part. What is this motion sickness? Motion sickness is defined as a syndrome of physiological response during movement or during travel to which a person is not adapted. This many of you have been experienced for the motion sickness. During a travel, you will be feeling a sensation of vomiting. It can occur while traveling in any form of the vehicle like automobile, ship, aircraft or a spaceship. Any kind of a travel will cause a motion sickness. That occurs while traveling in a watercraft is called as a sea sickness. What is the cause of this motion sickness? Motion sickness is due to excessive repeated stimulation of vestibular apparatus. As I told, the semicircular canal for a rotational movement and or utricle and a saccule, that is otolith organ, is for a linear movement. Both are repeatedly stimulated during the motion, either by rotational movement or by the linear movements, which will stimulate the receptors to generate the action potential and it will be sent to the brain. So, excessive repeated stimulation of the vestibular apparatus occurs because of rapid repeated change in the rate of motion while traveling. Because of the speed, change in the speed will lead to the rapid repeated change in the signals. This will cause and also the direction, rapid repeated change in the direction and the motion while traveling. This will get stimulated. Vestibular apparatus, that is semicircular canal and the macula The macula and the crista ampullaris will get stimulated by this movement, either by motion or by the direction. This will be stimulated. So these are the cause for a motion sickness. So what are the symptoms you will be experiencing in this motion sickness? Initially it will be nausea, next vomiting, sweating, diarrhea, paleness. If it continues more than that, it is excessive salivation, discomfort, headache and disorientation may start. Okay, these are the symptoms for motion sickness. So this motion sickness can be prevented by avoiding greasy or a bulky food before traveling or by taking anti-emetic drugs which inhibit the CTZ center, that is the center for a vomiting. So this regarding the motion sickness. So this is the topic. I generally summarize the topic. So what you read today is regarding the vestibular apparatus. So bony labyrinth, membranous labyrinth. In the membranous labyrinth, it is semicircular canal which are placed right angles to each other, anterior, posterior and lateral, which opens into the utricle, and utricle opens into the saccule, saccule will open into the cochlea. Okay. Then ampulla is the dilated part of the semicircular canal which contains a receptor. The receptor for semicircular canal is crista ampullaris. It has a crust with hair cell, supporting cells and plana semilunatum, that is epithelial cells which are arranged in the form of layer and secretes a proteoglycan. This is a crista ampullaris, receptor organs for a semicircular canal. Then this crista ampullaris has a two type of a hair cell. Type 1 hair cell with nerve calyx, the afferent will end in this, efferent will end in the surface. Where the type 2 hair cell, it is a test tube type which afferent and efferent both end at the surface. The hair cell, the cilia which project from there, the shorter ones are the stereocilia which link with the higher ones with the tip links. The stereocilia will link with the kinocilium. The tall one is the kinocilium. It's the movement of this stereocilia towards the kinocilia is activates the hair cell. Away from the kinocilium will deactivate, so the hyperpolarizes the hair cell. Then macula. Macula, like a crista ampullaris, macula is for a receptor organ for a utricle and a saccule. One is macula in the utricle, horizontally placed with respect to, they say horizontal with respect to the otolic membrane. This otolic membrane, the hair cell are vertically placed. In the saccule, it is vertically placed, hair cells are horizontal plane. Okay. Then nerve supply, first order neurons from the utricle and a saccule semicircular canal. They end in vestibular ganglion. Then they enter the vestibular nuclei. There are 4 nuclei: superior, medial, inferior and the lateral. From here there are 4 pathways: vestibulospinal pathway, then which ascends and end in the 3 cranial nerve nuclei, that is 3rd, 4th and the 6th, that is vestibulo-ocular nuclei. Then they end in a vestibular reticular formation that forms a vestibulo-reticular nuclei tract. Then they end in the flacculo-nodular lobe of a cerebellum. It is called vestibulocerebellar tract. So 4 tracts: vestibulospinal tract, vestibulo-ocular tract, vestibulo-reticular tract and vestibulocerebellar tract. So vestibulo-ocular tract function is, it is concerned with the movement of the eyeball in relation to the position of the head. Vestibulospinal tract, it is a movement of head and the body during postural changes. Then vestibulo-reticular tract concerned with the facilitation of the muscle tone. Then vestibulocerebellar tract with the coordination of the movement with the body posture. This regarding the nerve supply. Function, as I told, the semicircular canal for a rotatory movement. Then horizontal is for a linear movement. This diagram, when the head moves towards the right, head is moving towards the right, the endolymph will move initially in the opposite direction, that is towards the ampulla of the horizontal canal where the receptor organ is there. The cilia, stereocilia will move towards the kinocilium, which causes stimulation, that is depolarization of the hair cell. Then with a continued movement there is no stimulation of the hair cell, but during the stoppage, this is the initial stage, this is the stoppage. During a stoppage, the endolymph will continues to move towards the away from the ampulla, but in the opposite side it is towards the ampulla, because of which the opposite side horizontal canal will get stimulated by stereocilia moving towards the kinocilium. But in the same side, right side, because of movement away from the ampulla, it causes hyperpolarization or a stoppage of the action potential. This is regarding the function of semicircular canal for the movement of the head, rotational movement. Mechanotransduction, that is movement, it is a resting stage. Movement of stereocilia towards the kinocilium causes opening of the potassium channel along with the calcium channel. Then it's a continuous flow. Here is the generation of the action potential, and then release of the myosin band, which causes release of the tension in the tip links, causing closure of a potassium and a calcium channel, leading to the hyperpolarization or a stoppage of the action potential in the head cell. This is a mechanotransduction. Then coming to function of otolith organ, that is for the linear movement. The linear movement occurs due to the gravitational force, because of which these receptors are called as a gravity receptors. Then experimentally we can stimulate the semicircular canal, that is rotational movement, and the caloric stimulation. Rotational movement is by Baroni check, caloric stimulation by syringing of hot or cold fluid into the ear. The effects which causes the rotatory movements by Baroni chair are post-rotatory nystagmus, dizziness and vertigo. For long standing, it may also cause nausea and vomiting. In the closed eye state, in the open eye state, the nystagmus continues throughout a rotation. Caloric stimulation, that is syringing of a fluid into the ear, hot or a cold fluid, it causes nystagmus, vertigo and nausea. Then coming to applied aspect, bilateral labyrinthectomy, which removal of both the sides labyrinth, leading to equilibrium, severe or a complete loss of equilibrium. Postural reflexes are severely affected, whereas unilateral labyrinthectomy, less effect of postural reflexes, severe and autonomic symptoms because of unbalancing of a generation of impulses from the unaffected labyrinthine apparatus, which causes nausea, vomiting and diarrhea. Motion sickness, this is a nausea or vomiting during traveling. This is because the stimulation by the rapid repeated change in the motion and rapid repeated change in the direction. So this ends the topic. Okay, thank you. Any doubts you can ask.
dear students. Hope you attended my last class regarding recombinant DNA technology. We're just trying to recap it in 1 or 2 slides. Okay. What did we learn about recombinant DNA technology? What do you mean by chromosomal recombination? It is a way of rearranging genetic material between the homologous chromosomes, which happens during meiosis, and it results in the production of new genetic makeup which was otherwise unknown by usual splicing mechanisms. Okay. Why is it important? Because it has role to play in replication, repair and other vital processes of the body. It happens in vivo by itself to a certain extent, and we can also make it happen when you are interested in a specific gene. And these were the tools which were required for recombinant DNA technology, that is enzymes, restriction endonucleases, which help you to get the gene of interest out of the total DNA of the organism, DNA ligase, which helps you to join the DNA of interest, which is known as the foreign DNA, into the plasmids or the vector DNA, which can carry the gene of interest. Then reverse transcriptases are the enzymes which help you to convert the mRNA to DNA and then apply this procedure of recombinant DNA technology if suppose you are interested in the sequences contained in mRNA. Okay. So the insert DNA or the DNA of interest can be the DNA per se, or it can be a complementary DNA when it is obtained from mRNA. And the vehicles or the vectors used for transferring the gene of interest are plasmids or bacteriophages, plasmids, which are a combination of plasmids and phages, or viral vectors or shuttle vectors. And depending on the requirements for the technology, you either select a prokaryotic host or a eukaryotic host. Hosts serve as the factories for cloning. It is a place where the actual cloning or the multiplication of this desired material or this recombinant material that you are producing. Okay. This was the summary of recombinant DNA technology, wherein you either take directly the DNA of interest or obtain it from mRNA using reverse transcriptase, and then you also obtain the plasmid vector cutting with the same restriction endonuclease, and then you would have joined the foreign DNA of interest and the plasmid DNA to produce the recombinant DNA, also known as chimeric DNA or hybrid DNA. Now, in the next step, you will introduce this recombinant DNA into a host. Here it has been represented as a bacterial host. Okay. So, inside the bacterial host, you can see the specific recombinant DNA molecule as well as the host its own genetic material. Okay. So when you culture these cells under specific conditions, there is multiplication of both recombinant DNA molecule as well as the host its own genetic material. Okay. So by various steps you eliminate the actual DNA molecule of the host and you encourage only the recombinant DNA to multiply. Okay. So there will be amplification of the selected clone or that group of cells which contains only the recombinant DNA, and then you allow it to express into a protein and then isolate the specific protein for its application. Okay. Hope you understood. But this recombinant DNA technology becomes useful only when this artificially created DNA is reproduced in multiple numbers, that is using a technology known as DNA cloning. I think you are all aware of the term DNA cloning. Now we will go into the details of DNA cloning. Per se, cloning is a technique which is a Xerox machine or a copying machine for you where you can produce multi-individual. Okay. So now what is this molecular cloning and what is this somatic cloning? Okay. So these are two different things, but both are cloning. Okay. What is this gene cloning or molecular cloning? When a gene of a higher organism is introduced into a bacterial DNA, okay, it is known as molecular cloning or cloning of the gene. Okay. In otherwise, when you isolate a cell from an animal and it is grown into an exact duplicate of that animal, here you are producing the replica of the animal itself. Okay, it is known as cloning of an animal or somatic cloning. Okay, so molecular cloning is producing the replica of the gene in the host cell, whereas somatic cloning is producing the replica of an animal itself. Okay, what we are interested now is with respect to molecular cloning. Okay, I think you might have known about this, that it made a big news when Wilmot and Keith Campbell cloned a sheep by name Dolly in July 1996. I think most of you were not even born when it was done. So before you were born, the cloning process was already established. Okay, this is the procedure which they employed to make this Dolly, the artificially cloned animal. So this is an example of somatic cloning, or the cloning of an animal itself. Okay. So we will discuss about the molecular cloning now. So what are the strategies to produce gene cloning or the molecular cloning? You need to produce the DNA fragments, okay, using the restriction endonucleases, which causes digestion of the mRNA, and so using the reverse transcriptase you will produce the complementary DNA, and then using the PCR, polymerase chain reaction, you will multiply, or you can also chemically synthesize the gene of interest. Okay, we will discuss about PCR in detail later. Now, once you obtain the genetic fragment, you insert it into a cloning vector. So all these are the procedures which are very similar to recombinant DNA technology. Rather, these can be told as the advancement or the application part of recombinant DNA technology. Okay, so you will insert them into a cloning vector. Now then you introduce this recombinant DNA molecule into the host cells, and then you obtain the gene of interest or the protein of interest after its expression by selection or screening. Okay. There are various methods for gene cloning. This was already discussed under recombinant DNA technology. The most widely used is the transformation, where the plasmid DNA is taken up by E. coli in ice cold calcium chloride followed by a subsequent heat shock. This is the method of introducing the plasmid DNA. Okay. Other methods include conjugation, electroporation, liposome mediated gene transfer, or direct transfer of DNA into the cell nucleus. So how do you clone the human DNA in bacteria? So you basically cloning human DNA in bacteria, which is molecular cloning, using recombinant DNA technology. I told you that this is just an application of recombinant DNA technology. First, you have to introduce that recombinant DNA molecule. Okay, I think you know the procedure to produce the recombinant DNA molecule. Now, once it is ready, you have to introduce this into an appropriate host cell via transformation using calcium chloride and subsequent heat shock. Okay. So now the bacterial cells which contain this recombinant DNA are known as transformed cells. That means they contain their own genetic material as well as the recombinant DNA molecule. Okay. So I think one of the students asked the difference between recombinant molecule or the transformed molecule. Okay. This is just the almost it can be used interchangeably. So the bacterial cells after introduction of the recombinant DNA are known as the transformed cells. Now, how do you amplify this recombinant DNA technology? By incubating them stringently. Okay. And as it divides, the host cell replicates the chimeric DNA also in addition to replicating its own DNA. Okay. So subsequently, large quantities of the gene of interest or the human DNA can be produced and isolated, and under appropriate conditions, okay, you can even enable the expression of this human DNA so that that human protein can be isolated. Using a restriction endonuclease, okay, you also cut the gene of interest from the entire human DNA. Okay, this is just a small part of the entire human DNA. So both these are using restriction endonucleases. Then you use the DNA ligase enzyme to join the cleaved plasmid as well as the DNA fragment of interest to produce the chimeric molecule. Then you have the chromosome of the vector DNA. Okay, here it is bacterial cell. So by a process known as transformation, you create this transformed bacterial cell. Okay, and then you the bacteria are grown to amplify the recombinant DNA. So how do you obtain DNA? You can isolate the plasmids, cleave them with restriction endonucleases, and then isolate only the cloned human DNA. Okay, or in order to obtain the protein, okay, you can obtain either DNA or protein. In order to obtain the protein, you have to grow the cells under permitted conditions and then isolate the protein. Okay, these are the steps of cloning of human DNA in bacteria using this very good technology, recombinant DNA technology. Now, what are the applications of cloning in animals and plants? Okay, there are examples of animals being transformed into the animals with genetically desirable traits. Like for example, you can make cows yielding more milk using this technology. Okay, it also has wide applications in biopharmaceuticals, wherein in 1998 the first goats were produced which were genetically engineered to produce milk containing antithrombin 3. Okay, and cloning also has its applications in agriculture to propagate certain plants such as rubber, banana, orchids, etc. And those species which are threatening to become extinct can hopefully be easily reproduced using this technology. Okay, so that the word extinction becomes extinct. But disadvantages are also there with cloning, so it is not without any disadvantages, because it can never replace the selective breeding. Okay, it halts any further progress, and it can just reproduce animals or plants with the same characteristics. New characteristics could not be developed during using this technology, and the cloned animal and the parent need not be exactly identical. Okay, there are certain reasons to state this statement. That's because mitochondrial DNA, as you know, comes from the egg. Okay, and the DNA in an adult differs from a DNA in a fetal cell because of the accumulated damages of a lifetime. Okay, and any animal is not just the product of its genes but also of its environment, both in utero and after birth. Okay, so this is especially so with higher organisms who, okay, so this cannot be a total replacement of the natural process. So now, what are these gene banks? These are the outcomes of novel concepts where you have certain centers in many great cities of all the countries. Okay, where you can store an individual's DNA for future use. Okay, maybe it helps you in diagnosis of diseases in that individual. Okay, you will basically have a healthy copy of any individual who opts to store his or her genes in gene bank. Okay, if suppose the patient is exposed to mutation or some cancer or some other disorder later in life, you can always have a baseline copy of his or her genetic material in these gene banks. Okay, to refer to the original material and to detect the changes. Now, before we move on to gene therapy, I would like to show you a video of gene cloning.
DNA cloning is a method for isolating a particular sequence of DNA from a complex mixture of different DNA sequences. In order to clone a fragment of DNA, we need to insert it into a vector, usually a highly modified phage or plasmid that can replicate in a host cell. Generally, a plasmid vector contains three elements: a cloning site where the foreign DNA fragment can be inserted, a drug resistance gene which destroys antibiotics, in this case ampicillin, to allow selective growth of the host cell, and a replication origin to allow the plasmid to replicate in the host cell. To insert foreign DNA, we must first use a restriction enzyme to cleave the vector at the cloning site. Here, EcoR1 cleaves the common coding sequence GAATTC to produce single-stranded ends called sticky ends. These can hybridize with any piece of DNA that has also been cut with EcoR1. Foreign DNA containing the sequence we wish to clone is digested with EcoR1 and then mixed with the cleaved vector. The sticky ends of the foreign and plasmid DNA molecules hybridize and then are sealed into phosphodiester linkages by the enzyme DNA ligase, creating a recombinant plasmid. Each of these recombinant plasmids contains the inserted DNA fragment, an ampicillin resistance gene, and a replication origin. A pool or library of circular recombinant plasmids is thus created. Each plasmid carries a unique fragment of foreign DNA, as indicated by the colored arrows. Next, the host cells, E. coli bacteria, are added to recombinant plasmids. The cells are then treated with calcium chloride to make them permeable to DNA molecules. Through a process called transformation, a few cells take up a recombinant plasmid, while most other cells do not. The bacterial cells are poured onto a plate of nutrient agar containing the antibiotic ampicillin. With ampicillin in the agar, only cells resistant to the drug can grow. At 37 degrees, the cells will grow and multiply. Because they cannot move on the agar, each will produce a separate colony of cells. The non-transformed cells lack the plasmid with the ampicillin resistance gene and die. Cells that have a plasmid are resistant to ampicillin and survive. The replication origin allows the plasmid to replicate by using the host cell's enzymes. Plasmid replication is independent of host cell division, but plasmids are distributed to each donor cell when the host cell divides. As the plasmids replicate and the host cells multiply, the number of copies of the recombinant plasmid is greatly amplified. The multiple donor cells form a colony or clone. Because all the host cells in a colony are derived from a single cell, they all contain copies of the same recombinant plasmid with its fragment of foreign DNA. A variety of assay methods can now be used on the bacterial colonies to determine which contains the particular DNA sequence we wish to isolate.
I hope you understood with the help of the video. I think it's even more clearer now. Let's move on to the related topic, that is gene therapy. It is nothing but intracellular delivery of genes. So you are putting the genes exactly into the cells where you want to create the therapeutic effects by correcting an existing abnormality. So you are taking a normal gene, okay, producing it in multiple replicas and then introducing one of the best genes into the cells of the organism into which you are willing to produce the desired character, okay, so that the existing abnormality is corrected. Now how do you do this gene therapy? This is the summary of the procedure. You will isolate the normal or healthy gene. You will incorporate this gene into a vector to produce what is known as expression cassette. It is very much similar to the recombinant or the hybrid DNA molecule. This is called expression cassette here. Now you deliver this expression cassette contained in the vector to the target cells or the diseased cells where you are trying to replace the diseased gene with the normal or the healthy gene. Then you allow the diseased cells to multiply in number with the new normal DNA, and so that it returns to the normal state. Now, what do you mean by transgenic animals? Okay, in these animals, you can introduce the genes into the fertilized eggs. Okay, and this can form the animals known as transgenic animals. These animals can then produce the normal offspring. Got it? The fertilized eggs are directly introduced with these genes. Okay, and you develop transgenic animals from them. Okay, these animals in the next generation can produce the normal offspring. So the parent animal here, which is the transgenic animal, is called so because it contains the genetic material into which the DNA from a different organism has been artificially added. Okay, in the next generation it produces the normal offspring. And with respect to gene therapy, only somatic gene therapy is under trials, whereas the germline therapy is still considered unethical. So you should not be doing germline therapy. So there are various techniques for transferring the gene in gene therapy. One is using the viral vectors. The most commonly used ones are the retroviruses, adenoviruses and herpes viruses. Or you can also transfer them through the liposomes. I told you liposomes are bilipid layer molecules which can enclose themselves, and within the lumen of their own enclosure you can introduce either a protein or a drug or a hormone, anything you want to introduce. Okay, and then these liposomes are targeted to the cells where you want to bring about the change. Or they can also be taken up by endocytosis, or you can use artificial chromosome vectors. We discussed regarding human, bacterial and yeast artificial chromosomes, right? So you can use any of these, and there is a special therapy known as antisense therapy for gene transfer technique. Okay, if you know the methods, I think that should be enough. And then how do you deliver these genes? It can be ex vivo or in vivo strategy. In ex vivo strategy, the new genes are infused into the patient cells which are extracted outside. Basically, you take out the patient cells outside in the laboratory. So you take out them into a petri dish or a test tube, and then the modified cells are injected back to the patients. So you are incorporating the new gene in a place where it is outside the patient. So it is called ex vivo strategy. Rather, there is in vivo strategy also, wherein the vector is administered directly to the cell. Now what is this third one? In situ strategy. The expression cassette or the recombinant DNA molecule is injected into the patient intravenously. Okay, this is known as in situ strategy. Okay, this is very similar to the recombinant DNA technology, the various steps. Okay, so this is the example of ex vivo gene therapy, where you take out the cells of the patient, manipulate them and then introduce it into the patient. So these are the target tissues for gene therapy. What are these? Insertion of a normal gene into a diseased tissue depends on certain conditions, that is the proliferative state of the tissues. It should be a highly dividing cell, and accessibility to the gene manipulation should be there, and there should be control of gene expression in such cells. Only then these can become the target tissues for gene therapy. So the most commonly used tissues for gene therapy include liver tissues from liver, muscle, bone marrow, brain, fibroblasts, endothelial cells, glial cells, because all these are very much replicating, and they allow for gene manipulation, and they have a control over their gene expression. Now, are there any success stories of gene therapy? Yes. In 1990, a case of ADA deficiency, that is adenosine deaminase deficiency, was treated with gene therapy. So the patient name is Ashanti De Silva. She was a 4-year-old girl. Okay, she was diagnosed with adenosine deaminase deficiency and was successfully treated with gene therapy. Okay, there are many more stories to add to the success of gene therapy, wherein the first known example is the severe combined immunodeficiency due to adenosine deaminase deficiency, which I just discussed now, Duchenne muscular dystrophy, cystic fibrosis, familial hypercholesterolemia, hemophilia, cancer, Leber's hereditary optic neuropathy, Lesch-Nyhan syndrome, sickle cell anemia, thalassemia, Gaucher's disease, etc. have already been treated using gene therapy. Now, what are the commercial applications of gene therapy? They have applications in agriculture and industry also. In agriculture, you can produce certain plants which are resistant to diseases or herbicides or the drought or the temperature extremes, or those plants which are more efficient at fixing the nitrogen using this recombinant DNA technology. And you also have industrial applications where you can produce enzymes which are used in detergents, sugar and cheese, okay, using this recombinant DNA technology. Okay, but there are certain obstacles to the success of gene therapy because it has its own limitations. What are these? The results can be inconsistent. Okay, there can be lack of ideal vector, okay, into which you introduce the suitable gene. Okay, and there can be lack of targeting ability, especially with respect to non-viral vectors. We tend to avoid viral vectors because we never know when it may get reactivated and cause unwanted effects. And with one of the gene therapy cases, a death of the patient has been reported. So people hesitate to take chance. This was with respect to ornithine transcarbamylase deficiency. And the last but not the least, reactivation of retroviral vector is always possible, so it can lead to leukemia in a patient. Therefore, the trials on gene therapy are on, but are restricted with stringent protocols and follow-up. Okay, as an advancement to this gene therapy, we have introduced a concept known as genetic counseling. Okay, you must have heard of the very common phrase, prevention is better than cure. I think you all will agree. So what we are doing here is, it's a device to prevent passing of the defective genes to the offsprings. Okay, so we have certain screening tests based on this recombinant DNA technology, which can be performed on prospective parents, that is those parents who are planning to conceive, okay, can be screened prior to conception itself, prior to the conception itself. So once they conceive, the fetus can be tested for the genetic defect. Okay, if you detect the defect in the fetus, the treatment can be started at an early stage. The best time is when the fetus is still in utero. Okay, so this is what is the actual use of genetic counseling, and it also has applications in forensic medicine because of this DNA fingerprinting technology. Now, is there a scope for this gene therapy? Yes, because it offers a promise of many revolutionary changes in clinical medicines. Hopefully, we can cure the genetic disorders permanently by replacing the abnormal gene with a normal gene, and you can even correct the cancerous genes, or you can induce the cancerous cells to make toxins so that they kill themselves, so that only the normal cells prevail and the cancerous cells die off. Okay, or you can even block the viral genes using this gene therapy technology, or you can create stem cells from somatic cells. Okay, next, all these topics are short topics related to this technology. It can be asked as a 5-mark or 3-mark question. So I am trying to cover here itself because they are all related topics. Okay. Then you have something known as Human Genome Project. As the name itself suggests, it was a project taken up to decode the genes contained in the human genome. Okay. You must be wondering how was it possible? Yes, it was possible. The Human Genome Project is an international scientific research project, and it had a goal of determining the complete sequence of nucleotides of human DNA. Not just a single human DNA, okay, many varieties of human DNA. Almost sampling was done with every possible combination of genes in human DNA, where the complete sequence of all the nucleotides of all humans were, all types of humans were determined, okay, and they identified and mapped all the genes of human genome, okay. And at this point you should know that one set of human DNA contains nearly 3 billion base pairs, okay, 3 billion base pairs and approximately 10,000 genes, okay. So this is about each set of human DNA. This was an international effort by the US Department of Energy and the National Institute of Health. It was taken up way back in 1990. Again, well before most of you were born, okay. So James Watson headed the project first, was later followed by Francis Collins, okay. The project included scientists from 16 countries worldwide, okay, and it was in 1997, that is 7 years after the initiation of the project, that Mr. Craig Venter of Celera Genomics, who hastened the project, and it was completed by 2002. So 1992 to 2002, it almost took 12 years, okay, for the project to get completed, okay. And there were certain specific goals of this human genome project. The human genome project itself can be a 5-mark or 3-mark question for you. So you may be asked to write under these headings. So please listen. What were the specific goals of human genome project? The goal number 1 was to estimate the total number of genes, identify and locate the position of all these genes in the human genome. The second was understanding the dynamics of gene expression. This is just with respect to the structure. This is about the functioning of the genes, okay. The dynamics of gene expression with an intention to provide better diagnosis, treatment and if possible prevention of disease. And the third goal was to determine the sequences of 3 billion nucleotides of DNA and storing this information in database, okay, and developing tools for data analysis. So you are not just estimating, you are creating a database of all the human genes and genomes, okay. So since it is now complete, the human genome project is complete and we have the database of all the human genes, it is now possible to isolate any human gene of interest and compare it, okay. The book of human life contains 23 chapters, each of these chapters representing the 23 human chromosomes, okay. And another branch known as pharmacogenomics emerged out of the success story of this human genome project, wherein you use the knowledge of genetic information for the development of new drugs and their targets of action, okay. And as a continuation of this project, another project known as the ENCODE project, that is Encyclopedia of DNA Elements, was taken up in 2003. Since the human genome project was completed in 2002, the very next year the ENCODE project was planned by the National Human Genome Research Institute, okay, with a goal of identifying all the functional elements of the genome. So what are the applications and proposed benefits of human gene project? It has applications in medicine, where it helps in understanding the root causes of diseases and thereby enables us to develop effective treatment strategies, okay. In addition to its applications in medical field, it also has applications in biotechnology field, agriculture, environmental cleanup, okay. Now what is this DNA library? It is a collection of cloned restriction fragments of DNA that represents the entire genome, okay. Let me explain you. Restriction fragments of DNA, okay, and these have been cloned, okay, and it represents the entire genome. That means the entire genome of an organism has been taken and it has been subjected to the action of various restriction endonucleases, and the entire genome is cut into multiple fragments, restriction fragments, okay, and these have been cloned to produce multiple copies. I hope you understand, okay. So now we have multiple copies of the fragments of the entire genome, okay. And this genomic library can, DNA library can be genomic DNA library or complementary DNA library. Is there a difference? Yes. this genomic DNA library contains both introns and exons. Okay, it contains all the genes in a genome, whereas complementary DNA library is one where you have only the exons or the functioning parts of the genes. Okay, so over here the introns have been conveniently eliminated. In genomic DNA library, as I told you, it contains both introns and exons, so that you know every sequence of the genome of an organism. Okay, so how do you do this? You subject the entire genome of an organism, okay, to the action by the restriction endonuclease and cut them into multiple small pieces. Okay, these small fragments are then introduced into suitable vectors and clone. Okay, so you can summarize this entire genomic DNA library as a collection of different recombinant clones. Okay, so in order to produce this complete gene library, you require about 1500 fragments in E. coli and about 10 lakh fragments in human DNA. So it is sort of an Herculean task. Okay, this is the pictorial representation of genomic DNA library, where the human DNA have been cleaved with the help of restriction endonucleases. Can you see the multiple small pieces or the fragments of human DNA? Okay, and then you can see that few of the fragments have been colored. Okay, so only these fragments probably are the exons, the interested ones here. Okay, so these fragments are inserted into the plasmids and they are introduced into the bacteria and clones are produced in order to multiply their number. Now what is the second type of library, also known as complementary DNA library? Here only the exons are represented, okay, in contrast to genomic DNA library where both exons and introns are expressed. Okay, here cDNA library is a more specialized and exclusive DNA library. Okay, it excludes the unwanted sequences. Okay, so how do you do this? The procedure, you will extract mRNA from an organism, the interested mRNA, okay, and then you produce complementary DNA via a process known as it is sort of DNA replication itself, the reverse transcription, okay, wherein you are producing DNA using mRNA using reverse transcriptase, and then the resulting DNA fragments are inserted into a suitable vector and clone. Okay, so are you noting that all these procedures are very similar to the recombinant DNA technology? These are just examples of how well can you exploit this technology for multiple purposes. And since there will be no introns in mRNA, okay, the gene expression is easier. Okay. Now what are these stem cells? I think you have dealt with stem cells in detail in physiology, so I will just tell you in one or two slides which is relevant to this technology. Okay. Stem cells have the ability to divide for indefinite period of time, and they can give rise to a variety of specialized cell types, and this phenomenon of molding the stem cells into the cells which you want, into the specialized type of cell which you want, is known as developmental plasticity or sort of flexibility. Okay, and it is more in embryonic stem cells, okay, during their embryonal stages. And where do you get these stem cells from? It can be isolated from embryos or the umbilical cord. Okay, during delivery of the child you can collect the cord blood. Okay, so you can take stem cells from there or from any other adult tissues. Okay, since the plasticity is more in embryonal stem cells, we prefer to take the cells during the embryonal stage itself or during its birth at the umbilical cord. And active research has been done for the treatment of various diseases such as stroke, brain injury, Alzheimer's disease and Parkinson's, which are neurodegenerative disorders of the brain, wound healing, myocardial infarction, muscular dystrophy, spinal cord injury, and not to forget diabetes and even cancer. Okay. So what do you mean by totipotent stem cells? If the stem cells are capable of producing all types of cells, then they are called totipotent stem cells. If a set of stem cells can produce the cells of 3 germ layers, they are called pluripotent stem cells. Or if it can produce only closely related cell types, they are known as multipotent stem cells. Or if they can produce only one cell type, they are called unipotent. For example, if they can produce only the polymorphonuclear leukocytes, that is neutrophils, okay, they are called unipotent stem cells. So this is how the differentiation of totipotent stem cells occurs into hematopoietic cells, neural cells, mesenchymal cells, and then various tissues. So this completes the recombinant DNA technology. We will now discuss about the PCR, that is polymerase chain reaction. Okay, so I will give you 2 minutes. If you have any doubts regarding the discussion till now, please ask in the group, so that I will clarify and then move forward with PCR. Okay, since there are no replies, either I can assume that you don't have any doubts, or maybe you are not listening to the class itself. Okay, so let me ask you a few questions. Name some vectors which can be used in DNA technology or gene therapy or cloning. Okay, name some vectors. Name some vectors used in recombinant DNA technology. First, viral vectors. Then, very good. Name some non-viral vectors used in recombinant DNA technology. I want active participation from everyone. Okay, liposome mediated gene transfer, very good. Can you just name the non-viral vectors? So only one student is listening to the class, others are all sleeping. Good. Plasmids, cosmids, artificial chromosomes, very good. Very good. Okay. Can you name 2 applications of recombinant DNA technology? Just 2 applications of recombinant DNA technology. Applications of recombinant DNA technology. Okay, agriculture, human genome project. Okay, is there an application in medical field? What are its applications in medical field? Very good. Gene therapy. Then? Okay. I think you are all away. So let me just move on with PCR. Have you heard of PCR? I think you all had it in your +2 itself. So the PCR derives its name by polymerase chain reaction. As the name itself suggests, it is a chain reaction. You will follow certain steps and then you will propagate these steps in multiple cycles. Okay, so it is a chain reaction of a sequence of events using polymerase. Okay, so it is known as polymerase chain reaction. So basically it is a cell-free in vitro technique for the amplification of DNA, okay, where you intend to synthesize millions of copies of a particular sequence of DNA within few hours. Okay, so you are just completing the procedure within few hours. It is an in vitro procedure, so you are doing it outside the body of an organism. Okay, it is cell free. Okay, so you are not introducing a gene of interest into any cell. You are not doing that. Rather, it is a cell free technique, in vitro technique, and you are producing millions of copies of a gene of interest within few hours, not days or weeks. Okay, so how is it possible? And I must tell you that at the end of 30-second cycle of PCR, about million-fold target DNA can be synthesized. So if you can repeat the steps of PCR in cycles at the end of 30-second cycle, so you can produce million-fold copies. Okay, let us see how is it. Okay, so this technique was invented by Mr. Carey Mullis, and he was awarded the Nobel Prize for the same. Its applications are huge, okay, in clinical as well as forensic testing, and it has now become a very integral part of molecular biology. So using this polymerase chain reaction, DNA can be amplified from a single strand of hair or single drop of blood or other body fluids. Okay, where does this assume significance, especially in case of crime investigation? Okay, if suppose the culprit is very intelligent and has not left any evidence, you can still try to catch at least a single strand of hair of the culprit in the scene of crime, or a single drop of blood or other body fluids. Okay, and then using this you can always extract the DNA of interest and then multiply them in vitro to produce millions of copies, okay, using PCR. So the technology employed is very much same, that is recombinant DNA technology, which happens in vivo. Okay, so amplification of DNA using PCR versus that using recombinant DNA technology, which is done in vivo. Using PCR, it is very faster and technically less difficult. Okay, because with recombinant DNA technology, which is produced in vivo, it is very laborious cloning method. Okay, so it is a cell-free technique, in vitro technique, where you can produce millions of copies of DNA of interest in just a few hours. So it is easy and very convenient. So this is an equipment used to perform PCR. This works exactly like a Xerox machine, but for xeroxing the DNA. Okay, and you can note here that it is done in various cycles. The first cycle, okay, you take the double-stranded DNA molecule and then produce 2 copies. So it just works in an exponential manner. The first cycle, you can produce 2 copies out of a single copy. In the second cycle, each of these 2 copies will carry on its own multiplication. So 2 to the power of 2, so that is or rather 2 into 2, yeah, it multiplies. So you can produce 4 copies at the end of second cycle, and then in the third cycle, each of these 4 will give rise to another set of 4. So 4 plus 4 will become 8. So similarly, at the end of 35 cycles, okay, so you can produce 6, 8, 7, 1, 9, 4, 7, 6, 7, 3, 6 copies in just 2 hours. So can you imagine? Yes, it is really a wonderful technique. So it is working out in multiples. Okay, so each cycle, which happens in few seconds, okay, will produce the number in its doubles every time. Now what are the principles and steps of PCR? The double-stranded DNA of interest is denatured. What do you mean by denaturation? It is you are splitting up the complex nature of the molecule into the simpler nature or the primary structure nature. Here basically you are separating the 2 strands of the DNA into two different single strands of DNA, okay, which are complementary to each other. So to produce two individual strands. Now each of these strands, both these strands are separately allowed to hybridize with a primer. What is this primer? It is a short sequence of gene, okay, which is required to initiate the process of PCR. I'll discuss about primer in detail, okay. So this process of allowing the single stranded DNA, which is obtained by denaturation, okay, to hybridize with a primer is known as renaturation. So you are denaturing followed by renaturing, but renaturing with primer, not the complementary DNA strand. Now this primer template duplex, okay, is used for synthesis using DNA polymerase. I think you know the function of DNA polymerase. It establishes the bondage or the linkage between the adding nucleotides, right? So this is like your denaturing. This is very similar to the step of obtaining the gene of interest using the restriction endonuclease. So you are making it ready. The gene of interest is ready. Now you hybridize it with a primer, okay. So that is you are sort of producing a recombinant molecule, okay. And this duplex, that is the template DNA strand together with the primer, is used for DNA synthesis or extension, okay, using DNA polymerase. So these three steps of denaturation, renaturation are also called annealing and synthesis or extension, okay. These three steps are repeated again and again and again in cycles to generate multiple forms of target DNA. So at the completion of one cycle of amplification, the cycle is repeated. So you can note that here that initially there were two strands of DNA obtained following denaturation, okay. At the end of first cycle you get 4 copies, and at the end of second cycle you get 8 copies. Every time it is multiplied by 2, that is doubling. So the next cycle will begin again by, so following the first cycle, the next cycle again begins with denaturation, renaturation, synthesis, okay, of the strands which were formed in the previous cycle, okay. So in each cycle basically there is doubling of DNA strands. 20 cycles can provide us with 1 million times amplification. So if you keep on continuing the cycles of denaturation, renaturation and synthesis for nearly 20 times, so you can obtain up to 1 million copies of a single gene. So these are performed in an automated equipment known as thermocycler. This is PCR thermocycler. So this is again to represent the cycles. Initially you obtained a double stranded DNA molecule and you denatured it to produce two complementary strands of DNA. The second step, you add this primer. Primer is a short sequence of DNA oligonucleotide, okay. So each of these strands independently will lead to the synthesis of complementary strands. So the strand number 1 will get attached to this primer and produce the strand number 1A. So this strand number 2 will get hybridized to another primer and produce strand number 2A. So at the end of second cycle you have 4 molecules. Similarly, so if you keep on repeating the steps of steps 1, 2, 3, that is denaturation, renaturation and synthesis, you will get multiple steps. Now what are the requirements for PCR? So you need of course the DNA of interest, okay, which contains the target sequence, the sequence of nucleotides present in the DNA of interest, and it should be between 100 to 35,000 base pair in length. This is the capacity for PCR, okay. And you need 2 primers. Now what are these primers? These are synthetic oligonucleotides of 17 to 30 nucleotides length, okay. The yellow color structure which I showed you in the previous diagram, okay. These are 2 primers which are complementary to the regions flanking the target DNA, okay. Let me show you. Okay, so out of this total DNA, the dark blue one is the region of the target DNA which we are interested in. Okay, we are not interested in the other part of the DNA. Okay, so this is known as the target DNA. Okay, so the regions flanking, that is which are neighboring to this DNA of interest, have to be known. So you should know what nucleotides are existing at the ends of these DNA of interest, and accordingly you need to produce the primers, which are nothing but synthetically produced oligonucleotides. Okay, with an intention of attaching these primers to the ends of the gene of interest. And you also need 4-deoxyribonucleotides. These are the actual raw materials, so that you keep on adding these DATP, DCTP, DGTP and DTTP in order to produce the gene of interest. And in order to establish a bond between each of these pairing nucleotides, you require a DNA polymerase, and it is very important that this DNA polymerase is heat stable, because we will perform the process of PCR, that is, since it involves denaturation also, we will be performing it at high temperature of nearly 95 degrees centigrade. So the DNA polymerase which you are using should be heat stable, that is, should not be degraded by the great temperatures that you are using in PCR. And you also require multiple buffers and thin wall tubes, and the thermal cycler, which is a device, okay, which can change the temperature dramatically in a very short span of time. So if you have all these requirements, okay, so you can perform PCR with repeated cycles for amplifying the DNA. So what are the sources of DNA polymerases? You can get the DNA polymerase from E. coli, okay, or you can obtain, but this is heat labile, that is, it gets degraded by heights of temperature, it gets denatured. So the better ones are the Taq DNA polymerases, which is obtained from Thermus aquaticus, okay, which is found in hot springs. Okay, this is already heat resistant, and so that you can use them in PCR. Okay, so primers. What are these primers? DNA polymerase, the enzyme which joins the upcoming nucleotides with the existing nucleotides, requires primer to initiate replication. So it has starting problem. So it has it needs to have a primer, which I already discussed about. Okay, these basically primers are short single stranded DNA molecules, okay, which are sequence specific. So these should be having a sequence which is complementary to the flanking regions of DNA of interest. Flanking regions are nothing but the neighboring regions. Okay, so you should first know which gene you are interested out of total human genome. You should note the sequences neighboring to these gene of interest, and then you should design primers in such a way that they contain the nucleotides which are complementary to the flanking regions. Okay, so you design the primers. If you design primers of longer length, it becomes more selective. Okay, so it is therefore necessary to have the knowledge of nucleotide sequence of the flanking regions to prepare the primer. Okay, so we just learned about what is PCR, what are the principles behind PCR, and what are the requirements for PCR. In next class, I will continue about the stages of PCR and its application, and then we move on with another technique. So if you have any doubts, please ask in the live chat. Okay, if you do not have any doubts now, just go back and read the textbook Okay, and then you can send me your doubts via WhatsApp. Okay, thank you.